So let's check now our third problem in our quiz. We have this beam here, and we have this force distributed triangular shape force of 5 Newton per meter, which means we have here vertical reaction of YA, and we have here vertical reaction of YB. If we consider this point B and this point A, and we will ignore the horizontal reaction of the pin support because we don't have any horizontal forces here like we normally do. So let's start by calculating sigma of the moment at point A, which will equal to 0. So we have YB multiplied by 10 equals to, we need to calculate the area of this load, of the triangular distributed load, and the location of the resultant. So it is 5 multiplied by 10 multiplied by 0.5. This is the value of the resultant, which is the area of this triangle shape. 10 multiplied by 5 by half, because this is a triangle shape, and this will be multiplied by the distance, which is 6.67 meter, because we know that the centroid of any triangle is 1/3 from the base and 2/3 from the other side. So it will be here. So the third of the 10 meter is 3.33 meter from this side. So the remaining distance will be 6.67. So solving this equation, it will result on YB equals 16.7 Newton. Taking sigma forces at Y direction equals 0. It means that YA plus 16.7 equals 5 multiplied by 10 multiplied by 0.5, which is the vertical force. So it means that YA will equal to 8.3 Newton. Now we have all the reactions, and we can start calculating anything we need. Here he wants in this problem to calculate the moment at distance of 7 meter, something here. So we want the moment at distance of 7 meter. So let's draw this triangle. This is our triangle, and this is our load. This is 5 Newton per meter, and we have this distance of 10 meter. We want now to calculate a distance of 7 meter, which is something here. So we need to calculate this value x, which is the load at point of distance of 7 meter from here. So now we have this at 10 meter, the load is 5 Newton per meter, sorry, and at 0.7 meter we want to calculate the x. So it could be stated as x over 7 equals to 5 over 10. Solving this, x will equal to 3.5 Newton per meter. So now we have the load. We can draw this portion of the beam now, which will look like this. 3.5 Newton per meter, and we have here vertical reaction of 8.3, and this distance is 7 meter, and we want to calculate the moment here. So the moment will equal to the following, which is 8.3 multiplied by 7. This is going in this direction, minus the moment due to the distributed force, which is going in the other direction. That's why we put it in negative sign. Minus 7 multiplied by 3.5 multiplied by 0.5. All of this is the value of the force, multiplied by 7 over 3, which is the arm, because we know that this whole distance is 7 meters, so the third is 7 over 3, because this will be the location of the resultant force. So solving this equation, we can obtain that the moment equals 29.5 Newton meter. So this is it for our last problem in our quiz. Thank you.